Okay, this is like this. This is a continuation of there we go. Thank you. Right, this is a continuation of exercise 6.6. Question, we're just going to look at some of the questions. The ones we didn't have logs or trig functions in them. We're just doing a few questions. So exercise 6.6, motion and differentiation. The main thing is x is displacement, v is the first derivative, which is the velocity, a is the derivative of the velocity, or the second derivative, and it's the second derivative, which is acceleration. Velocity can be written as x with a dot and acceleration x double dot, and we know displacement's just x. All right, let's look at some questions. Just going to look at another few questions in this exercise. Question 11, because it's a log question. So the displacement of a particle is given by x equals log to the base e of t plus 1, where x is in centimetres and t is in seconds. Find the initial position. What's that asking you? Find what when what is what. So we've got x equals log to the base e of t plus 1. Part A, find the initial position. That's asking you to find x when t is 0. If you can do that, please. Okay, so x equals log to the base e of 0 plus 1, or log to the base e of 1, which is just ln1, which is 0. So therefore the particle is initially at the origin. Part B, find the velocity after 5 seconds. Whoops, what do you have to do? Differentiate. Yep, differentiate. And, all right, you do that. I'll pause. So the rule is if y equals ln function of x, that's the rule, then y dashed is 1 on function of x times f dashed x, or it's f dashed x on f of x. So that would be, differentiate the t plus 1, what do you get? You get 1. So it's 1 on t plus 1, no logs. So what you might want to do is, look, your function of x is t plus 1, f dashed x is 1. So therefore, the velocity is dx dt, which is f dashed x on f of x, which is 1 over t plus 1. If you have to do all that setting out, I suggest you do it rather than getting it wrong, okay? Or have your rule in front of you, write down fx, write down f dashed x, just don't mess it up, all right? So when t is 5, the velocity is 1 over 6, 1 over 5 plus 1, which is 1/6. What are the units? Actually, what are the units for the first one? Well, velocity is dx dt, so it's distance over time. Dx dt means change in distance over change in time. That's what it means, the rate of change of distance. So it's the distance units divided by the time units. So you look back up here, and your distance units are centimetres, and your time units are seconds. So it's centimetres, seconds to the minus 1, or per second.
Is acceleration to -2?
Yes. So you can write it like that. So you okay with that now? So dx dt, distance, change, dx means change in distance. dt means change in time. All right? C, acceleration. So how do you differentiate that? Remember, A is dv dt. A is dv dt, which is the derivative of that. Now, girls, you don't have to use product rule. So I'm just going to write v equals 1 over t plus 1. How can I rewrite that?
T plus 1 to the -1.
Yeah, do not go using the quotient rule. Why? There's only one function. There's no function on the numerator. Quotient rule and product rule are for two functions. I can only see one function in t there. And why is it a function in t? Because you're doing dv dt. Sorry?
If it, like for part B is after 5 seconds and part C is after 5
Yes, I know. But first you've got to work out the equation for acceleration and then you substitute t is 5. So dv dt, so acceleration, which is dv dt, is, what do you do? Differentiate. Negative 1 bracket, t plus 1 to the times, because you're differentiating inside, don't forget, which is, wait, over t plus 1 squared, which is, so now when t is 5, acceleration is over 36, because it's 6 squared is 36 units. Well, if the units of velocity are centimetres per second and you're dividing by seconds again, it's centimetres per second per second. So it's centimetres per second divided by seconds, it's centimetres per second per second. All right, what does this mean? What does negative that mean? The acceleration's acting to the left. And velocity's acting to the right. Very good. Oh, very good. Notice at 5 seconds, girls, velocity's acting to the right. 1/6 centimetres per second, it's positive. Acceleration's acting to the left. So if we just look at what's happening at t equals 5 seconds, this is what's happening. Velocity to the right, acceleration's to the left. So the particle's travelling to the right and speeding up or slowing down. Good. So describe the motion of the particle at t equals 5. So it's travelling to the right at, you can put the speed if you want, at 1/6 centimetres per second, but it is slowing down, or you can put decelerating. Decelerating at a constant rate. At a constant rate of 1/30, because there's no t next to it. Oh no, it's not constant. Get rid of that. Not constant. Yeah, I will. It's not a constant rate because there's still a t in the equation. I'm sorry. Definitely not a constant rate. If there was no t here, if you just ended up with a value of, say, -2, that would be constant without the substitution. But I did have to substitute at t is 5. So it's not. Decelerating at a rate of that. D-E-C-E-L. Slowing down, or in other words, just put slowing down. They probably just want travelling to the right and slowing down. They probably don't even want the speed.
Do we put the negative?
No, if you say no, the negative just gives you the direction, just like we don't give a negative for the velocity. You have to take into account that velocity is to the right, acceleration to the left. That tells us slowing down at that rate. Now, last bit, the exact time when the particle will be 3 centimetres to the right of the origin. So here's the equation. Part E is find the exact time when the particle is 3 centimetres to the right of the origin. They're asking you to find t when x equals 3. Right. 3 equals log to the base e of t plus 1. Aha. Okay, so for those that love the formula, y equals log to the base a of x, then you read backwards, x equals a to the power of y. So, or those that like to take what will cancel your e, it's log to the base e is taking e of both sides. So if you take e of both sides, you get e to the power of 3 equals e to the log e, that cancels, t plus 1. But that works like this, x equals, whatever the a is, it's e to the power of 3. So t plus 1 is e to the power of 3. So therefore t equals e to the power of 3 minus 1. That's the exact time. Seconds. Which is approximate of a spring, has a height given by h equals 3 sine 2t centimetres, where t is the time in seconds. Find the initial height. I'm sure you can do that. Guys, what does this look like? It's a Do you remember your trigonometry? This is a sine curve. Tell me, let me just draw it. So it's a sine curve. Instead of putting 1 and -1, what do I put? 3, great. And then instead of putting 2 pi here, well, what's the period? Let's just do it down here, just some revision. Period is 2 pi over b or whatever. So it's 2 pi on 2, which is pi. Now you can think of this in two ways. You can think of the 2t or 2x as in I can fit 2 of them in the normal space. Or you do 2 pi on b, which is 2 pi on 2, so the period's pi. So instead of going 2 pi here, what do I put here? Pi. I'm not saying you have to draw it for this question. You don't have to. But it actually will really help. Now remember, this is in radians. So that pi, this is, guys, what axis is this, by the way? Which axis is this? It's the t-axis, and this is the h-axis. And what value is this? All right, and this is approximately 3.14 seconds. That's about 1.57 seconds. All right? That's pi on what? And that's 3 pi on 4. So you know how it's saying find, well, actually we can answer the questions from the graph, but we will use the formula as well. But just by looking at the graph, what's the initial height of that particle?
0.
Good. Find when the spring is at its maximum distance from the origin. There. At pi on 4 seconds, it's 3 centimetres, because that unit is in centimetres there. Because look, h is 3 sine t centimetres, okay? So it's 3 centimetres to the what? Right or left of the origin up here? Plus 3. Down here it's 3 centimetres to the left. So you would say at those times, at there it's 3 centimetres to the right, at this time it's 3 centimetres to the left. And the acceleration, we'll look at that in a minute. All right, let's start. Find the initial height. So you can do it from there or we can substitute. So aren't they asking to find h when t equals 0? So h is 3 sine 0, which is 0. So initial height is 0. In other words, it's at the origin. B, find when the spring is at its maximum distance from, yes. Well, wouldn't it be, so using the graph, look, when you do extension and simple harmonic motion, you'll always be doing this sort of stuff anyway, and you're going to be more comfortable using the graph anyway. So using the graph, maximum distance from the origin, and I think you are meant to use it, but we will differentiate, is when t equals pi on 4 seconds, where you are 3 metres to the right. And I'm also going to put the -1 because it's still, they want maximum distance. So t equals -3 pi. They're not asking for maximum displacement. And t equals, not -3 pi on 4, and t equals 3 pi on 4 seconds, where you are 3 metres to the left.
They have 5 pi on 4 and ...
They got 5 pi on 4?
Yeah, it says pi on 4, 3 pi on 4, 5 pi.
Oh, yeah. So therefore, it's when t is pi on 4, 3 pi on 4. If you did continue that, where do you think the next one will be? Up here? They've gone 5 pi on 4. The next one would be 7 pi on 4 ... seconds. Guys, if they're doing that, your best thing is to use the graph. If you don't want to use the graph, you know what you're going to have to do? You're going to have to differentiate that, get the cos curve, put it equal to 0, find stationary points, then you're going to have to do both the maximum and the minimum and do the second derivative. It's just too much work. So no, we're not doing it. C. With C, we're going to use, so they want the acceleration at this time, at that time, at that time. Just by looking at the graph, you can't tell the value, but you should be able to tell me whether the acceleration is going to be positive or negative. The acceleration at this point, just in terms of concavity, remember acceleration second derivative. You can't work out the value, but you can tell me, actually, isn't the velocity up here the gradient? Velocity is 0. All right, let's just do the derivatives. Right, what do we got? H equals 3 sine 2t. But wouldn't the acceleration be negative, concave down? And at this other one, isn't the acceleration positive? And all that means is that acceleration's acting to the left, acceleration's acting to the right. Guys, this is a particle move.
Don't you just differentiate it till you get to acceleration and then sub in one?
Yeah, that's what we're going to do, but I'm just trying to get you to understand what the graphs mean. I'm just trying to, when you get a negative answer for acceleration, guys, it's just that you will get questions with graphs involved where you're going to have to interpret from the graph.
Miss, how do you determine acceleration?
You can't from that graph, I don't think, because, yeah, you can't. Pretty sure you can't. All right, let's just do the things. So h is that, velocity is dh dt. Come on, how do you differentiate a sine curve? 3 times. Differentiate sine, you get cos 2t. Then what do I do with that? Times 2. So I get 6 cos 2t. And then acceleration is dv dt, which is, well, if we just differentiated sine and the sign didn't change, it's about to change now when you differentiate cos. What do you get? 6 times negative cos. Differentiate cos, you get sine. Negative sine 2t times 2, which is negative 12 sine 2t. So now we put in our different values.
Let me just put in 1 because it should be the same, isn't it?
No.
Should be the same when it's a certain.
Look, here you should get a negative value, there you should get a positive value. Concave down, remember this is x. Second derivative is acceleration. Second derivative on a curve is concavity. Do you remember that?
Yeah.
First derivative is speed.
So how many?
Well, I'm thinking you should get a negative value here, a positive value there.
Yeah.
Concave down, concave up. Guys, that's why I'm referring to the graph, because it'll help you with interpretation questions later. I know I'm sort of sidetracking, but, you know, often the questions aren't just so straightforward. They'll require interpretation. So when t is pi on 4, the acceleration is negative 12 sine 2 pi on 4. That's negative 12 sine pi on 2. If I draw the sine curve, what's sine pi on 2? Well, that's 2 pi times 1. So it's negative 12.
How do you know?
Because pi on 2 is there.
Yeah.
That's the sine curve. 2 pi on 2, negative 12 times 1 is negative 12 units, centimetres per second. You know how we said it is downwards? So in other words, the acceleration is 12 centimetres per second to the left, and so therefore acceleration equals 12 centimetres per second to the left. And for the other one, yes, you can tell I'm using an exam booklet, just old ones that they're just spares, like scrap ones that you guys used in exams. All right, you got that? And then when t is, what's the other one? When t is, I think 3 pi on 4 was the next one. Acceleration is negative 12 sine 2 times 3 pi on 4. That's negative 12 sine 3 pi on 2. 3 pi on 2 is here. What's that? It's negative 12 times negative 1 is 12 centimetres per second, which means, because sine 3 pi on 2 is down here, it's negative 1. That's pi, 2 pi, halfway is 3 pi on 2. Sine of 270 is negative 1. So it's 12 centimetres per second. In other words, the acceleration is 12 centimetres per second to the, this acceleration is 12 centimetres per second to the right. Girls, if this particle's swinging, which I think it is, or moving up and down, I think it's swinging, It's moving in, it's moving to the left, it's moving to the right, it's moving to the left, it's moving to the right. That's why acceleration goes from left to right to left to right. Now, this acceleration, every second hump of your graph, I suppose you can call it, when it's concave down, the particle's moving to the left, the acceleration's to the left. The original graph, are we okay or not? Do you know what I'm saying? So if I continued, can I move? If I continue here, acceleration's negative, acceleration's negative, acceleration's positive. Down here, acceleration's positive. Negative, negative, positive, positive acceleration due to concavity. Going to do is question 19. So part A is there and part B and C are here. Okay, so start with question 19A. A particle is moving in a straight line so that its displacement x centimetres over time is given by that. Now, what sort of rule are you going to need to use to differentiate? Okay, yes. First question is, for how many seconds does the particle travel? It says, for how many seconds does the particle travel? We haven't seen questions like this, all right? Because you've got a square root and you've got the t squared there, once you hit certain values of t, you cannot have the square root of a negative number. So what we know is that 49 minus t squared has to be greater than or equal to 0. Okay? Remember 7 minus t, do you remember this? But look, you don't have to do it this way. But how would I do this? This is good revision as well. This is an inequality, quadratic inequality. You do not sketch those without you do not solve those without sketching. How do you sketch it? Look, you don't have to. 7 and negative 7. And what is it? Concave up or down? So therefore, do you remember how to sketch this? What? How to solve this? Yeah, t lies between negative 7 and 7. So I've got negative 7 less than or equal to t less than or equal to 7. But t has to be greater than or equal to 0 as time is positive. It's a quantity. So therefore, t lies between 0 and 7. Now that's the formal proof. The other way is the common sense proof. You can't have negative t's because they don't exist. You start with t is 0, that's fine. You can see here once you go over 49, 49 minus 49, once t is greater than 7, you're going to get negative values under the square root, and that's not allowed. So this is the way that you do it, maybe with domain and range, with domain, okay? Or you can just do it by looking at it. I'm happy for you to just do it by looking at it, but you must have the 0. So for how many seconds? Therefore, the particle travels for 7 seconds. You can just do it by observation, all right? Part B. I'm trying this little hand thing, and it doesn't want to move. All right, I'll fix it. I'm pausing. Okay, find the exact time when the particle comes to rest. So what do they ask you to find? Find t when v is 0. So you need an equation for v. You don't have one. So x is t times the square root of 49 minus t squared. What are you going to do with that? T times 49 minus t squared to the half. You're going to do your u dash, your v and your v dash, dx dt, which happens to be v. All right, I'll pause. You keep going. U is t, u dashed is 1. V is 49 minus t squared to the half, so v dash is a half, 49 minus t squared to the power of negative a half times 2t, which is just t times 49 minus t squared to the negative a half, or you can write it as t over the square root of 49 minus t squared. With this type of question, and I did forget the negative, it's negative 2t, negative t, negative t. Very good. So, what have we got? uv dash plus vu dash. U, t, v dash. I just put them over the square roots. Keep them as square roots. I think it's easier. So u times v dash, oopsie, oh no. All right, you keep, t times negative t, it's negative t squared over the square root of 49 minus t squared, plus v times u dash, isn't it just the square root of 49 minus t squared?
Wait, why is it negative t?
Because it was a half, 49 minus t squared to the negative a half times the derivative of minus t squared is minus negative 2t. So it becomes negative t there, negative t there. So we've got t times negative t over that plus 1 times that is 1 times the square root of 49 minus t squared. We're just going to substitute. We're just going to substitute what? What are we doing? Substituting? Hello? V equals 0. You know what? Probably the factorising would have worked better, but we get 0 equals negative t squared, square root of 49 minus t squared plus the square root of 49 minus t squared. How are you going to solve this, girls? I'd take this one over. You can. I'd go t squared is 49 minus t squared times the square root of 49 minus t squared. So I've just picked that up and taken it over. Now you can cross. T squared is the square root of 49 minus t squared all squared, because it's that times that. Are you okay with that? T squared divide by that, opposite is timesing it by that. It'll be square root of 49 minus t squared times 4. So there's the continuation of that. T squared is that, taking the t squared over 2, t squared is 49, t squared is 49 over 2, t is plus or minus the square root of that, which is plus or minus 7 on root 2. Time is positive, so t is 7 over root 2. Now for part C. How far does the particle move altogether? What do you need to know before you can do this question? We have done things like this before. What is it important to find out? Does the particle stop and go back? So, did we ever look?
Couldn't we just work that out when velocity equals 0 and 20?
Fantastic. So, this is what we've done so far in this question. We know that the particle only moves for 7 seconds. So we need to see what happens to the particle in the first 7 seconds. We know that at time 7 over root 2, the particle stops. So let's find, we know where we were originally. Where were we originally? Do we know at the start? So we need to work out where we are at the start. Yes, we are at 0, but you'll need to show it. Then we need to work out where we are at time is 7 on root 2. And then we need to work out where we are at time is 7. Okay, let's go. So we've got x equals t square root of 49 minus t squared. So when x is 0, this is initially, no, not when x is 0, when t is 0, x is 0 times 49 minus 0, it's 0. When t is 7 over the square root of 2, x is, got what we're doing? Because it stops. It either stops and keeps going or it stops and moves the other way. So x is 7 on root 2 times the square root of 49 minus t squared is 7 on root 2 squared. So it's 7 on root 2 times the square root of 49 minus 49 on 2. Can we go common denominator? 7 on root 2. Can we go common denominator? What's 98 minus 49? 49 on 2, which is 7 on root 2 times, amazing, 7 on root 2, which is 49 over 2, which is 24.5 metres. So we know at time is 0, so this is our sketch so far. At time is 0, the particle's at 0. At time is 7 on root 2, the particle's at 24.5 metres. You better work out at t equals 7, where is the particle? X is 7 times the square root of 49 minus 7 squared. So it's 7 times 0 is 0. In other words, the particle's gone like that and it's come back. So how far? Therefore, the distance travelled is 24.5 plus 24.5. In other words, it's travelled 49 metres. Because it travelled from there to there and travelled back. So at time is 0, it was there. At time is 7 on root 2, it was there. And at time is 7 seconds, it was back at 0. Do you get it? So when time was 7 seconds, it's back, displacement is 0. So therefore, it must have gone there and come back. Does it make sense? Sorry? Oh, what's the question? No. The question's not what's the displacement. How far does the particle move altogether? That is how far what distance has this particle travelled? Displacement 0. Okay, we'll do more of that next lesson when we do some Cambridge ones. Homework, please, for homework, just finish off anything that we haven't done in this exercise. I think from 11 onwards, there's about 7 questions left. Try question 20. You have to differentiate sine squared t. Oh, do you know how to do that? No, that's not integrating it. I'm talking differentiating it. Sine squared t is sine t times sine t. You either go 2 sine t cos. You put sine t squared, differentiate 2 sine t cos t. See how you go. We'll probably do it in class.